Good morning, everyone. Thank you for joining us today for our webinar. Today, our webinar will be on intelligent ECAD-MCAD collaboration with the Solidworks PCB Connector. My name is Meaghan, and I am the subscription manager for CAD Micro Solutions. Our presenter today is Jamey, Larocque, and to give you a bit of a background on Jamey before we get started. Jamey received his electronics engineering diploma from College Royal in Sudbury, Ontario. He is fluent in both English and French and has a combined 6 years of experience using Altium Designer and Solidworks PCB. Today he's going to give us a clear understanding of the capabilities and how the software can be used to solve from simple to complex electronic designs, and just a brief agenda of what we're going to go through. Today we'll be exploring the PCB connectors and learn how collaboration between your ECAD and MCAD departments can move more seamlessly. We'll be exploring the configuration of board shapes, mounting holes, and component placement in SolidWorks. You'll also learn how to track design changes through the PCB connector panel. And there will also be a Q&A period at the end where you can ask Jamey some questions, so you can type those questions into that chat area. You can type it throughout the presentation, but we won't address any of the questions until Q&A. So if you have any questions during the presentation, feel free to send those through. I will read those to you during the Q&A, and then please stay to the end of the presentation where we will give you some of our end of quarter promotions and also let you know what's in store for the next webinar and the benefits of being a subscription customer with CAD Micro Solutions. And with that, Jamey, you can take it away for us. Thank you so much.
Awesome. Thanks so much, Meaghan. Thank you for the great introduction. Can you please confirm my audio is okay and that you can see my PowerPoint?
You sound great, and I can see your PowerPoint with a 3D compass and an arm.
Awesome. Perfect. So once again, thank you to everyone who has joined us today. It's really a pleasure to have all of you a part of our webinar on the Solidworks PCB connector. Before we get started, for those who are interested in a full product overview of Solidworks PCB, or if you want information on any other technical videos that we've made, simply speak to one of us and we can definitely give you to a link to any pre-recording of a webinar or any of the technical videos that we have created previously. So please don't hesitate to reach out to us. We will be going over a few short PowerPoint slides before we get into the demo itself, just to get an idea on what the PCB connector actually is and learn a little bit more of some of its key features. Some of you may have noticed by now, but the Solidworks PCB and PCB connector are powered by Altium. So although the product may seem new to some of you, it has been in the market and has been going through some aggressive enhancements for quite some years now. So it's with confidence that I can say that Solidworks PCB was built on more than 50 years of combined experience between Altium and Solidworks to be able to provide you that electromechanical product that best suited both design environments for the ECAD and the MCAD teams in terms of collaboration. So as most of us know as designers, when it comes to electronic or mechanical designs, decreasing development costs and improving the time to market are two of our main design challenges. And we know we need to get the product out the door as quickly as possible and sometimes also as cheap as possible. So the real question is how can we achieve these two objectives? And our answer is with the Solidworks PCB connector. So we all know the electronic and mechanical domains are two sides of the same coin, really. Getting a product's form and fit correct the first time is a critical part of a product's success, and that seamless collaboration between these domains is really essential for product schedules and budgets. So the connector itself will eliminate any of that separation between the two domains with the intelligent collaboration, making our data and our workflows connected. So all of this communication of design changes are recorded within the PCB connector. So we can see who made the changes, on what day and what time, as well as any comments of the changes that were made through the PCB panel. So I will also show you how we can preview each design change, and the designer will be able to decide if they want to accept or discard any of those changes. So it really puts you in the driver's seat with this, and with that communication built inside of the tool, it eliminates any file exchanges between designers, and there's no need to go back and forth through emails talking about what changes have been made or need to be made. So you'll see throughout the presentation, I'm actually not going to import or export any designs. It's all going to communicate seamlessly from ECAD to MCAD. And in PCB design, we know that, sometimes 2 or sometimes even 3 prototype iterations are common. And according to the Aberdeen Group, the cost of one prototype is about $8,900. So that's potentially about $27,000 just in prototyping, depending on the complexity of our design. So they realized that customers really needed an integrated solution that was going to help solve this problem. And this is where the true value of the PCB connector comes into play. So today I will be showing you how we can start our project with a JTAG enclosure within Solidworks. We can configure our board shape, and we can push that over to the electronic designer to start their PCB layout process. And sometimes the project itself is driven from the mechanical realm, and the PCB designer must be aware of what real estate he or she has to work with. So I really wanted to cater this to the mechanical group. So without further ado, let's hop right into SOLIDWORKS Mechanical and go from there. So as I stated, we're just going to have a pretty basic enclosure here for a JTAG adapter. And essentially what we're going to do is we're going to want to bring in a PCB into SOLIDWORKS to configure our board shape, because we want to have that board shape right the first time and make sure that it fits. So you'll see here over on the right-hand side of my screen, we have the SOLIDWORKS PCB add-in panel. So this is actually where we're going to communicate from ECAD to MCAD between the two softwares. So this panel is a simple add-in that needs to be enabled within SOLIDWORKS, and it'll communicate with SOLIDWORKS PCB. So let's go ahead and take a look at our enclosure, and I'm simply going to hide the shell for now, and we're going to take a look at really where the PCB should be sitting. So we can see here we have multiple tabs on the inside of our enclosure, and we're probably going to want our PCB to sit nicely on top of these tabs. So instead of actually waiting for the electronic designer to give us a board design and say, here, fit this into the enclosure, we can actually start this from the mechanical realm. So we can see here that I'm going to start a new board assembly. And what this is going to do is we can either decide to pull it from an existing project or create a new project. So in here, I want to have enclosure for JTAG, let's say, and we're actually going to create our default 3-inch by 3-inch PCB board in SOLIDWORKS, and it's going to actually create a new assembly for us. So we can see here I already have my PCB board in the mechanical realm. Once again, no file exchanges were needed. I started my project from the SOLIDWORKS PCB panel. So if we go into our enclosure assembly, we are simply going to insert this PCB into here. So as we can see, the board is a little bit large for the enclosure, and it's obviously not going to fit as is. But what I would like to do is I would simply create a coincident mate between the bottom of the board and that tab, so I know that it's properly going to be sitting exactly where I want it. So we can see here, yes, the board is a little bit big, but we have a great starting view of where we think our board is going to be sitting. So what I'm going to do is simply edit this sketch, and I'm going to remove this. And as the mechanical designer, you're obviously going to be designing the sketch in which you want the board outline to take. So you might be an electronic designer doing mechanical design as well. So this is going to be very beneficial for you as well if you handle both sides of the design. So we can go ahead and convert the entities of our sketch, and we can see there we get a great preliminary view of what our PCB board will look like. So let's go ahead and accept these changes. And we can see there, within a matter of maybe a minute or so, we've already converted our nice sketch into our PCB board. Now let's go ahead into our assembly, and we see here it's automatically updated. So since I've inserted that component into the top assembly, it automatically updates. when we pay attention a little bit to this panel over to the right, we have the project name and we have push and pull. So the push and pull essentially is going to be what we're going to use to communicate back and forth between our two design environments. So let's go ahead and push these changes over to the electronic designer and say configured board shape. And we can go ahead and post that. And we can see there, it says by me, and it has a timestamp of which day and at what time this comment and these changes were made. So once again, there's no communicating between email, no back and forth. Everything is done through the panel itself. So now that we've configured the board shape, let's go ahead and open up SOLIDWORKS PCB. And we're going to go ahead and we're going to open this project. And we can see here the project is already visible within SOLIDWORKS PCB. We didn't have to create a new project. So as the electronic designer, you're more than certainly going to have at least a schematic ready. So let's go ahead and add our schematic and our PCB. And we can see here that we have our default 3-inch by 3-inch PCB as we've seen in mechanical. But one thing that's new for us is we see the SOLIDWORKS PCB connector panel that says new changes have been detected. So this is as simple as going to View and simply opening up that SOLIDWORKS PCB connector panel. So what we're going to do is we're going to go ahead and we're going to view these changes. And we can see here it's going to give us every change that's going to be made. So this can be components, board outline, placement, anything like that. But the real great thing about this is I can actually click on each change and get a preview of what's happening. So we see here that we're really going to update real time our board shape within our PCB. So let's go ahead and accept that change. And we see there we did not have to do or make any changes in the electronic realm. We already have our board outlines. So, you know, it's really that bi-directional communication that's going to save us a lot of time. So this is going to be as simple as importing our components over from our schematic. And we're simply going to go ahead and place these for the time being. The component placement is not crucial at this stage as we can change them in either environment. So I'm going to purposely move these connectors off to the side where it doesn't make sense, and I'm going to show you how we can configure those changes in SOLIDWORKS Mechanical. Okay, so let's go ahead and push these changes, and we can say added components. Please configure. So once again, it's going to track all of our changes so we can go step by step and see exactly what was added when. So when we go back into our assembly in SOLIDWORKS, we're always going to have these new changes that have been detected and what the latest changes have been. So it's going to give you an update each time. So let's view those changes. And it's also going to bring in our models as well. So if I click on LED 2, we can see it wants to add it. And maybe we want to have this connector here. And it's going to give us a preview of where we want it. So let's go ahead and accept all these changes. Once again, it's going to bring in all of the models, and it's going to add the same placement as we had in our electronic environment. So we can see here we're looking pretty good, but I want to view this in my top assembly. So let's go ahead and see that and say, okay, well, you know, we have to make some small changes, but that's really not a big deal. So what we're going to do here is we're going to move some components and we're going to create some cutouts for our LEDs because obviously they can't simply go through the board. We want to ensure that there's enough clearance. Okay, so let's go ahead and edit this. And I'm simply going to move with the triad as I don't want to change their y-axis, their z-axis, sorry. I simply just want to move some of these components to reflect their component placement. Maybe this connector, we can see it's going to have some interference issues. So once again, just move this over a slight bit and maybe just pull it back a tad. And same goes for this final connector. Oh. And there we go. And I will simply pull it back and we can see there it looks okay. So let's go ahead. We will accept these changes. And last but not least, but we will go ahead and make those cutouts for the LEDs. So I can simply go ahead and I'm simply going to sketch on the board itself, and I'm going to make our cutouts for our LEDs. Doing all of this work within the electronic environment can be very time consuming. So this is something that the mechanical designer can do as well and really take advantage of that bi-directional communication and ensure that you're all on the same page when making changes. So we can see here I made a very nice cutout for the LED, and I will go ahead and do the same here as well. Of course, there's going to be multiple ways to do this, but this is simply the route I am taking at this time for demo purposes. And let's simply go ahead and extrude cut this through all. Let's accept these changes. And we can see there our component placement is looking much better. Our cutouts are looking good. But you'll notice here that whenever I move this component over, it still leaves behind a couple of these mounting holes that we had from the electronic environment. But not to worry at all, because whenever I go and update this again, it's going to recognize that the component has shifted, and it's actually going to update those mounting holes to the proper placement. Okay, so now that we've made those changes, we're good to go ahead and push back into the electronic environment. So we configured the component placement and added cutouts for LEDs. Once again, I've not had to import or export any files. Without this real-time collaboration, you would probably have to export as a step file, and if changes needed to be made, then you would actually have to tell the electronic designer to make those changes and recommit and give you that new step file. So this is really going to save you a bunch of time going back and forth real-time through the PCB connector. So a good visual as well is that we can actually see the preview of our components that have been moved over. So you know exactly what their previous positioning was, and you know their new positioning as well. Let's go ahead and we will accept all these once again. And I just have a little bit of clearance issues since I have a component touching the LED, but I will simply move that over for the time being. So we can see here in 3D, we have exactly what we have in our mechanical realm. We've created board cutouts, we've configured our component placement, and we've really created that board shape within a matter of seconds, where, believe it or not, whenever I was designing, I would actually print a one-to-one scale, and I would actually cut that piece of paper and put it in my enclosure to see if it fit. So not only was that really time consuming, but it also wasn't an accurate way of finding out, especially if you have tight tolerances, if it's actually going to fit in the enclosure. So this is really the only tool that's out there that is going to have this real-time collaboration. Now, one thing that's going to maybe happen is down the line, you might want to add standoffs in your enclosure, some plastic standoffs, or maybe some bosses where you want to actually have a mounting hole where you want to add a screw. So that's absolutely no problem. So we can actually add those mounting holes within the electronic environment. And I'll simply make this 100 mil for the time being. And we might have something as so. And when we look in 3D, we have our 100 mil mounting holes, and we're good to go. And once again, we're always going to be pushing and pulling from one environment into the other. And I can simply go back into Solidworks, and as you can see, just by opening the window, I couldn't even beat the time it took to make those changes. So it really is real time. So let's view these changes. And we can actually see where they're going to add the mounting holes. And as I told you previously, the mounting holes that we're getting changed for our component that we moved over, we can see here that it's actually going to make those changes. And I had to move my LED over just a tad. So let's go ahead and accept that. Perfect. It's added our mounting holes. They look great. going to go check this out in my top assembly. But as a mechanical designer, I might say, well, you know, 100 mil was going to fit for our last mounting screw, but maybe we went to something that was a 1/4 inch, or maybe we needed something that was a little bigger. Let's say, I don't know, 150 mil versus the 100 mil holes that we made. So that's absolutely no problem because we can make those changes within SolidWorks. We don't have to wait for somebody to do it in SolidWorks PCB. So we can simply go ahead and edit this sketch. I will simply smart dimension it. We're going to add 50 mil to it. We can see there we made it a little bit larger, and I will go ahead and do the same on this side. So it really gives you free range as a mechanical designer to give you a little bit of insight into the electronic world of things and vice versa. You know, since the PCB layout is one of the most manual parts of an electronic design, we really want to minimize the time it takes to do the layout with board configuration and component placement within the mechanical realm as well. So let's go ahead and we are going to push these new changes over to our electronic designer. And we can see here, out of all the changes I've made, we have a timestamp. So we can see here, we started at 110, and we've been going back and forth. And all the changes that we've made within 10 minutes would actually be hours without this tool. So this is something that's really going to save you a lot of time and a lot of effort, and it's going to really eliminate those error-prone processes. So let's go ahead and we will accept both of these changes for the holes. We can see there it has made the mounting holes much larger, and if we want to compare our 3D board in SolidWorks PCB to our assembly in SolidWorks, it's pretty much looking identical. So we can see here it only took me 10-12 minutes to do so, where I would struggle for hours previously doing this and still not get an accurate board shape or component placement when it came from the electronic to the mechanical world. So although we've only really touched on the surfaces of what the tool can actually do and explore its full potential, this real-time collaboration is what we really wanted to focus on and show to you that that's going to be the bread and butter of collaborating between these both design environments. So this is something that's going to make you much more efficient and save you a lot of time when designing. So I really hope this was beneficial for all of you that are doing mechanical and electronic design. Like I said, this need for collaboration between the two environments has never been more crucial than now. And to have something like this is really exciting for us too. So I hope it's exciting for you. So thank you very much for attending. I hope this information was pertinent to you and you can potentially use this in your design workflows. And I'll give it back to you, Meaghan. So thank you very much for joining us today.
Perfect. Thank you so much for your time today also, Jamey. If you have any questions, please type those in right now for Jamey. Any questions at all, guys, please do type those in for us, and we will address those right away.
And once again, for those... Oh, sorry, go ahead, Meaghan.
No, you can go ahead, and then I'll read you the question that just came through.
Excellent. I just wanted to reiterate for those of you who would like a little bit more in-depth information and maybe something a little bit more complex, we do have those videos and those blogs that exist. We have multiple sites in which that you guys can visit for these videos and these blogs. So please don't hesitate to reach out to us and we can give you that information. Absolutely no problem.
Awesome. And so one of the questions that came through during the beginning was, during the PowerPoint, I noticed it said it was powered by Altium. Is Altium going to be developing the product?
Right, so that is a good question. So SolidWorks will be doing all of the development and enhancements when it comes to SolidWorks PCB and the connector. It was originally developed by Altium, and when acquired by SolidWorks, they really wanted to ensure that the connector gave us the true collaboration that's been missing between the ECAD and the MCAD environments for so long. So on top of this, for those that are using Altium Designer, the connector can be purchased so that those users can also have this type of collaboration. So it's really advantageous to those that are using Altium Designer currently, and moving forward, SOLIDWORKS will be doing all the development and enhancements.
Perfect. And Jill, another question that we have right now is, how does the communication work between both SOLIDWORKS PCB and SOLIDWORKS 3D licenses?
So the way the PCB connector works is that the connector is a feature that is standard within SOLIDWORKS PCB, and the communication is done in two ways. The first being through the PCB services. So the PCB services would be installed on a server that is common to each the mechanical and the electronic designer, and all those changes that are being made are being tracked through that service. Or if you happen to be doing the designs for both ECAD and MCAD, then you could host the services locally on your machine. And the second way that the SOLIDWORKS PCB communicates is that it's actually an add-in for SOLIDWORKS. So the add-in simply needs to be enabled in SOLIDWORKS for the collaboration panel to appear.
Perfect. Thank you so much, Jamey. Do we have any more questions coming through? We do. One second. I'm just going to read this out for you, Jamey. Floating mounting holes for connector CN1 were not moved. Do you need to move them manually, or is that just the remainder you need to clean up?
I hope I understood the question appropriately, but whenever I added the mounting holes, I believe he said if we wanted to make a change to the placement of those mounting holes, you could move the placement manually within SOLIDWORKS or SOLIDWORKS PCB. So as I edited the sketch and Smart Dimensioned it, you can simply move that sketch over somewhere else on your board. And as long as you do the push and pull between the two environments, the component placement should not be an issue. When it came to whenever I moved the connector and the mounting holes stayed behind, once I updated it once again, it realized that it had shifted places. So it then adapted its new positioning. So it is manual for you to move the mounting holes, but you simply do the push and pull, and you only have to do it within the one environment. So I hope that answered the question.
Perfect. We do have more questions, and we will get through as many as we can, and if we don't get in, because we do respect your time, I will send the questions to Jamey, and we'll get back to you, of course. Does this work for SOLIDWORKS Mechanical? We did get through that. I would like more information. For sure, we'll definitely get more information to you. On the mechanical side, part of the connector was floating, and the holes are still visible on the mechanical side.
Correct. So whenever I move the connector, which is CN1, we can see here that previously the holes were stationary even after we moved over the connector. So since it's coming from the electronic realm, it does not yet know that it has moved places. So as I was saying, once we did another push and pull, the information that was pushed from the electronic side back and forth, it realized that the component now had shifted placements. So unfortunately, as it stands, I don't believe those holes will move with it if that component has been moved. You simply have to do another push and pull, and it's going to adapt its new positioning. So I just had stated that whenever I moved it, that the holes didn't move with it, but it simply takes one more push and pull for it to update.
Perfect. And if we do have any questions still, guys, please let Jamey know, and you can type those in right now, but we will be getting to those over email. If you have any questions immediately you'd like technical support with, you can email our technical support team at support@cadmicro.com or call us at 416-213-0533, and when you hear the automated voice, just press 1 and you'll be connected with the next available application specialist. And if anyone has any other questions for Jamey, again, do type them in. We will send them. I do see a lot of people requesting additional information. And as Jamey said, check out our website, cadmicro.com, for information. But our YouTube channel is also a great resource where Jamey and a lot of other application specialists have done videos on YouTube on the CAD Micro channel that you can take a look at, and it really walks you through Solidworks PCB. Thank you so much, Jamey, for your time.
Thank you, everybody, for your time as well. It's been a pleasure.
And on the line, I believe we do have one of our account managers. Nick, are you there? Hi, Nick. Are you there? Sorry, guys. We're just going to wait for Nick because Nick is going to go through some of our promotions for Q2. Hi, Nick. I'm not sure if Nick will be able to join us, but that's okay. I can go through some of the promotions that we have right now. I know I did not put a lot of information on these slides, and hopefully if Nick jumps in, he can always share more. But we do want you to reach out to us directly so we can really go through what promotions are happening and if these are the right software for you. So for the current promotions we do have Solidworks Electrical and Solidworks PCB. So please, you can always send me an email, mkhan@cadmicro.com, and I can get more information to you. But there are a lot of different promotions happening where you can save up to and over $14,000 for your new software. We also have the simulation bundle where there is over $10,000 of savings when you upgrade your software and include the simulation package there. And right now, we have the price of premium at the price of standard. So you're really getting a free upgrade to premium with the purchase of new standard license. And if you'd like any additional information about these current promotions, please reach out to us and we'll be very happy to provide those to you. And for our subscription customers, as always, we do have our MCAD ECAD clinic. You can schedule your session. You can walk in or we can do these sessions online over GoToMeeting and you can share your screen so we can address some of your recurring design challenges. You can register for this directly on our website, on our online calendar, or you can also just send me an email and I'll help you get registered. We also have our upgrade training, which is provided to all customers complimentary with every new version release, and we have those scheduled every Friday right now, running on site at our Toronto and Cambridge offices. So please check out our calendar, see which date works best for you, and do come in and learn what's new in 2017 and how you can use the new features to improve your design process. And as always, CAD Micro Solutions is your complete provider of your MCAD ECAD solution needs. And if you have any need for software or hardware, we are here to help you. We also provide 3D Mark IV printers, and we can help you with your computer hardware to upgrade as well. So if you need anything at all, please reach out to us and we'll be very happy to help you. Our next webinar will be on July 19th, and it ties in very nicely with the ECAD series we've been running. We are going to go through our electrical files and show you how you can manage that in Solidworks PDM. Earlier in the year, our colleague, Taha, did a webinar on Solidworks PCB. Saeed did a webinar on Solidworks Electrical, and Jamey's come step inside it really nicely with the PCB connector. So our colleague, Harpreet, will be going over how you can organize these files in Solidworks PDM. So do join us on July 19th, and you will receive our invite so you can sign up and register for that event. Again, if you have any technical support issues, please feel free to contact technical support at support@cadmicro.com or call us directly, 416-213-0533. Thank you, everyone, for joining us today, and thank you for your time. And if you have any questions, please feel free to send them over to me. You will receive the email tomorrow with the recording and additional information and the slides as people have requested. Thank you so much and have a great day. Thank you, Jamey.
Thank you, Meaghan. Great job.